Okay, 8th graders, just going to quickly talk about this lesson. Some guys missed part of it because you're writing the quiz. Right, so we're talking about the definition of a function yesterday. Okay, so in the most general sense, a function is a rule that assigns to each input value one output. Okay, so if we look at this question here, the function rule says that y equals 16t squared. So we can fill in the chart, okay, and say, okay, so for the 0.5, okay, you can say y equals 16 multiplied by 0.5 squared, and that would tell you the value of y. So y then equals 4. And if you apply that rule to each different value of t here for time, you get 4, 16, 36, 64, 100, 144, 196, 256. Okay, so if we look at the distances in lesson 1, then you would actually find that they would actually match the table from the previous lesson, so this is yes. Okay. And is this going to be accurate? Explain. And we talked about this a little bit. We also said yes to this. And again, the functions have these predictive values, right? So when we have this thing, or this rule or equation that says 16 multiplied by t squared is going to actually help us find the distance. When we use different values of t that are outside of our table, such as like 3.75 or 8 seconds, whatever, what have you, we can use the rule to actually make a prediction. Okay, so that's, if you actually measure this thing in real life, you might get something that's a little bit different, but usually when we set a function rule to a situation, it's going to be generally pretty accurate. Okay, so in this slide, what you're supposed to do is just figure out whether the table represented in here represents the function or not. Now the answer to this first one is no. Okay, it is actually no. And why is that? Because if we look at the input 5, we have a value equal to 19. And if we look at this 5, we'll have a value of 20. So in this case, one input has two outputs. Okay? And because that happens, we're just going to say no or not a function. Okay? Because that's the rule that for every one input, you're going to have a distinct or one output. Now let's skip down to number 4 here because it's a little bit of a different situation. Okay, so number 4, we have this table, 10, 20, 50, 75, and 90 as input. And then we have these outputs. But one thing you'll notice, if you look at the numbers, you'll say, oh, I see a 32 output here and a 32 output here. So is that the same thing as like question 2 there? And the answer is no, it's a little bit different because each, again, input, there should be an N there. So 10 and 20, okay? The 10 input is 32. The 20 input is 32. So the two inputs can have the same output, but the thing is, two inputs can't have two outputs. Okay, so for instance, then 10, you can't see somewhere on this table later like a 10 and 50, or that would mess things up. Okay, so again, by definition of function, for every one input, you get one output. Okay, so you can't get two outputs. So in this situation, number 4, it's a little bit tricky. So you can get two outputs that are the same, given that the two inputs are different. Well, for question 5, it's kind of like a different style problem. And this one, you actually have to create the function rule before you kind of get into the questions. So we're looking at Josephine, and she can do her homework in a certain amount of time. So she can do 10 problems in 34 minutes. Okay, and so if we assume she works at a constant rate, how many problems can she do in, say, 25 minutes? Okay, so constant rate is really important, because if we don't have a constant rate, this problem is just not going to work. So generally speaking, okay, when we're dealing with questions that have constant rate, we say that the rate times another unknown value, x, equals y. So the rate, k, is the ratio of x to y. So in this case, we can make y the number of problems and x the time. Okay, so, and usually that would kind of make sense, because the amount of time would dictate how many questions she could do. So what we got here then is 10 over 34, which we could reduce to, let's see, 5 over 17. And as you can see, I've moved to the NPR, and there's just a little bit more noise. So here we go. So if we take that constant then and put it into the equation, we're actually going to create our rule, where y is equal to 5 over 17 multiplied by x. Now the question is a prediction question, right? It's saying predict what she can do in 25 minutes. And if we're saying x is time, then we can figure this out. We can say y equals 5 over 17 multiplied by 25. And that's going to tell us how many questions she can do. And I think, yeah, I don't have a calculator in front of me, okay, but that's going to be, what, 125 over 17? And you can divide that with a calculator, okay? Okay, so turning things over, part B says write the two variable linear equation that represents her work rate. It's just what we had done in the previous question. So we got the first variable, y, and we know that this rate was constant, 5 over 17, and then we're going to multiply by x. So this is our function. Okay, so we're going to use this function to complete the table. And I think the rest of your homework should be good. All right, thanks a lot. See you later.